Hi, in this session, we'll see one of the soil exploration methods, that is the seismic refraction. The soil exploration method is based on the principle that sound waves travel faster in rock than in soil. This is on the account of the fact that velocity of sound travels is different in different media. In this method, the shock waves are created into the soil at a ground level to certain depth below it, either by striking a plate on the soil with a hammer or by exploding a small charge. The shock waves so produced travel down into the subsoil strata and get refracted after striking the hard strata below the surface. The refracted and or the radiated shock waves are picked up by means of the vibration detector. It is called as a geophone. Okay, it is called as a geophone, where the time of travel of the shock waves gets recorded. Knowing the time of travel of the primary and the refracted waves at various geophones, tune and the distance graph are drawn based on which it is possible to evaluate the depth of the various stratas in the subsoil. This is the picture of the geophone, which will gather all the, pick up all the vibrations. It is a vibration detector and it will give you the time of travel. Different materials such as clay, gravel, silt rock, hard rock have the different characteristics of seismic velocities. Hence, it is possible to establish their identity in the subsoil based upon the time distance graph. This is the when the incident ray is getting strike on the surface, some of the waves will get refracted, that is, it is getting passed, and some might have reflected. Whatever the waves, whether it is reflected or refracted, it will be observed by the geophone. It is a vibration detector. Okay, the source which produces the sound, it is getting reflected, and the red color waves are getting refracted. Okay, the picture clearly explains how the seismic reflection is happening. Okay, for example, this layer is the larger depth layer is the sediment, and below that is the bedrock. Okay, a pit is made in the site. The geophones or the detectors, we can name it as per our convenience, maybe G1, G2, G3 and so on, are placed on the ground. The geophones or the detectors used depends on the depth of the pit. Geophones are connected to the seismograph. Here is the seismograph, which is a recording device. The elastic waves are created due to the explosive action. See, a person is blowing his hammer. These waves will move in all directions. Some of the waves which are created reaches the geophone. Say it is getting, the rays are touching the bedrock and it is getting reflected. All the reflected rays are observed by the geophones. The waves travel through the uppermost soil is called as the direct wave. Some waves get refracted in the second and the third layers are recorded by means of geophones as electrical pulses. So here it is getting in all the geophones, it is getting observed. The time which is taken by the waves after explosive actions are get refracted from the original path is called as a critical time. The critical time noted here is T1 plus T2. The time will be noting down in T1, T2, etc. The distance from the energy source behind which the refraction of waves takes place is called as a critical distance. This is a critical distance. Okay, the critical distance here are x1 plus x2 into y1 plus y2. From this, we'll be calculating. See, for the different depth of the soil beds are shown. Sediment is existing only for the smaller portion. Bedrock is for the larger thickness. Here, there it is seismic reflection. Here it is refraction. Anyhow, we'll be calculating this by using the formula. So, the depth of the different layers such as clay, gravel, silt, hard rock are calculated as follows using this formula, where y1 is the depth of the layer, v1, v2 are the velocities of waves in the layer, t is the critical time. With this we can calculate these, so we can explore the soil. Thank you.